Okay, so short video to hopefully help you solve any titration calculation question. Just before we start, that's the equation that you're going to need. I'm hoping that you're familiar with the concept of changing equations into triangles. So there we've got concentration equals moles over volume, and you just cover up whichever one it is you want to work out. So if they're next to each other, so moles is concentration times volume. Volume is moles divided by concentration, and concentration is moles divided by volume. The concept of those triangles, right? That's going to be important. So first question I'm going to look at is this one. So 30 centimeters cubed of 0.25 moles per decimeter cubed sodium hydroxide reacted with hydrochloric acid. The mean volume of hydrochloric acid used was 32.6 centimeters cubed. It's giving you the balanced equation, and it wants you to calculate the concentration of hydrochloric acid. Now, this is a tricky concept, it's a tricky question. The most common answer on the exam for this is 0. People just leave it blank, they've got no idea what to do with it. They go, oh my god, not only is it a maths question, but it's got loads of words in it and a balanced equation, and they just skip it. But this is, if you can get it right, it's extra marks in the bag, hopefully a high grade. So how would you tackle these questions? So the way which should work for any question, I'm just going to try and arrange this so you can see the question as well. Okay, so the easiest thing to do is to start, work out what chemicals you're dealing with, so the sodium hydroxide and the hydrochloric acid. So I'm going to write NaOH over there, and I'll do them in separate colour pens to help you do it, and hydrochloric acid there, and then draw your little equation triangle for each one. So we've got concentration equals moles divided by volume, and then we've got concentration equals moles divided by volume. So we've got our two triangles, one for each substance. Now we're going to fill in the numbers that we know. So we've got a triangle here. I'm going to draw it a bit bigger so I can write them all in. What do we know about sodium hydroxide? Well, we know it was 30 centimeters cubed, so that's the volume of it. So we know 30, but it's in centimeters cubed, and we need to turn it to decimeters. So we do 30 divided by 1,000, which equals 0.03. So 0.03 decimeters cubed. So that's the volume. We know the concentration. It's 0.25 moles per decimeter. We don't know the moles. Now we come over here to hydrochloric acid, fill in the triangle. We don't know the concentration. Well, the only thing they've told us in the question is the volume, 32.6, but it's in centimeters cubed, so we need to divide it by 1,000, and that is 0.036 decimeters cubed. I'm just going to tidy that up a bit so it fits in the triangle a bit better. 0.036 decimeters cubed. So we don't know the moles. Then we go back to look at the question. What is the question actually asking us? The question wants to know the concentration of HCl. Let's get all the colour pens out. Right. The question is asking us the concentration of HCl. That is here, concentration of HCl. We can't work out at the moment because we need to know the moles. That's an issue. But what do we know? Well, over here, we know the concentration and the volume, so we can work out the moles of NaOH. So let's do that. So we use our triangle, 0.25 times 0.03, type that in your calculator, and you get 0.0075 moles. So we know how many moles of NaOH they've got. And then this is the key. We look back to our balanced equation. There's no big numbers in this equation at all. We need to know how the moles of NaOH, how that is linked to the moles of HCl. And this is where we go back to the equation. In fact, again, I'm going to do this in a different colour. So orange, how the moles of NaOH is linked to the moles of HCl. That's based on this equation up here. There's no big number in front of the NaOH, which means we know it's a 1. There's no big number in front of the HCl, which means we know it's a 1. So that tells us it's a 1-to-1 ratio. So 1 mole of that reacts with 1 mole of that. Or 50 moles of that reacts with 50 moles of that. Or 3 moles of that, 3 moles of that. It's 1-to-1 ratio. So that means if we know it's 1-to-1. So if there were 0.0075 moles of NaOH, then there must be 0.0075 moles of HCl. Now we can work out the concentration. We know the moles, we know the volume, so we do moles divided by volume, so 0.0075 divided by 0.036, and that gives us our concentration, which was the answer to the question, and that equals 0.23 moles per decimeter cubed. Now, let's just check to make sure we haven't messed up any maths. If we look back at this, we know they're a 1-to-1 ratio, right? We know we had 30 centimeters cubed of 0.25 mole per decimeter cubed. We had to use a little bit more hydrochloric acid. We had to use 32.6. So we used 30 of that and 32.6 of that. So they should have been, and if they're a 1-to-1 ratio and it's roughly the same amounts, we'd expect the hydrochloric acid to be roughly 0.25. But we haven't used 30, we've used ever so slightly more. We've had to use 32.6 instead of 30. So because we've had to use more of it, we can tell the concentration is slightly weaker. So we're after a number that's in the same ballpark as 0.25 moles per decimeter cubed, but it's slightly weaker. So something slightly weaker than 0.25, and our answer was 0.23. So perfect, slightly weaker, brilliant. So this is what I would do for any titration question. Put your 2 reactants up here, put the triangles, write in the bits you know about each one, and then this is the key bit, this orange thing here, that tells you the ratio. If, for argument's sake, and I'm just going to use a totally separate equation now, let's say we were dealing with sulfuric acid, and this is the one, it's normally either hydrochloric acid or sulfuric acid. So if we had NaOH plus H2SO4 goes to Na2SO4 plus H2O, and we need 2 of those, 2 of those. So this is the part. So I'm just going to pretend for a second we had exactly the same numbers here, but it was sulfuric acid instead, H2SO4, and then so that would be the sulfuric acid and sulfuric acid. So same question, but we've just changed the acids. So if you look here, the ratio is 2-to-1. So when we're doing the ratio bit now, so we worked out it was 0.0075 moles of that. That part hasn't changed, but the ratio is 2-to-1, which means, okay, so for every 2 of these, you only need 1 of these. So you have to half it. You have to divide it. To go in that direction, you'd need to divide by 2. So this would be 0.0075 divided by 2. And that is what you use the equation for. So write your triangles, fill in what you know, link the moles to the moles by the balanced equation. Hopefully that clears it up for you.